There is a moon treaty which talks about how we will use moon for the benefit of the humanity without creating conflict, etc. As per Elon Musk, he says he will create lakhs of people to move there, create Mars colonies. Moon could be much easier.
Chandrayaan 3, because it was such a global headline. The entire mission costed a lot less than, making the movie Gravity as a comparison.
Today we have launched up to 104 satellites in one go.
Wow.
You are not even allowed to touch with your finger. Your sweat touches, it will corrode and get damaged. Going to moon was criticized upon at some point in time, but it's no longer. The first uncrewed mission will happen this year.
Okay. So very soon in near future we'll see Indian astronauts going to space in Indian rockets.
No doubt about it. No doubt about it. There are two schools of thought. One is a moon-based economy and another is a Mars-based economy. Life on Earth was destroyed at least 4 times by external influences. Wherever the startups and companies coming in space sector, application sector, service delivery, I am able to see lesser risks and huge returns.
And are the air taxis nearly there? Can we expect them to be part of our lives soon?
I believe so.
How many people does ISRO hire each year?
Not much, possibly around 200 to 250 people.
Okay, so that many positions available.
India has to have our own space station.
Mr. Somanath, welcome to SparX. Really excited about this conversation. I want to start with Chandrayaan 3 because it was such a global headline in I think July 23. I think one of the line that most people are using that the entire mission costed a lot less than making the movie Gravity as a comparison. What is at the core of ISRO has been able to do such amazing things at a budget which is probably an order of magnitude lesser than what people in the West do? What do you attribute to that to? Like, how are we able to do things so efficiently?
There are many elements to it. Before that, thank you so much for having me here in this program. Talking to you is really an honor. I have been watching many of your podcasts, which is really informative for people like me. Thank you so much once again. And this is a question which I generally hear. Many people ask me, especially when I go out of this country, and there is a lot of huge interest in understanding what is the secret. But I must tell you that there are many, many elements. It's just not one. The first and foremost is the concept of frugal engineering, of how to do things at minimum cost. This is already embedded into our thought process of the organization. When we plan something, we are very much aware that if you ask more money, we are not going to get it. No, this is an internal learning. So we work around and find out how to really use as much as possible that which is already done and do a little bit of the new things which will, which is necessary for that mission to proceed. So this is the first element. Second is that we have a concept of model philosophy. For anything that you do in aerospace, there is a concept of model philosophy. You need to make an engineering model, you need to make a proto, then you make a qualification model, then you make a flight model, you make a standby. So for all of these models that you need to provision, money, hardware, product, time, etc. So many a times we trim it to sometimes we call proto flight model. There is only one model. And the rest of those things are only in breadboard or maybe in simulation. So number of models are substantially reduced. Even our rocket building, we have seen that we have only 2 static tests before we actually fly. Whereas others, 6, 7, 8, 9 tests are done in the ground before we actually fly. So the question will be asked whether are you taking undue risks? Of course there are. But then the confidence of understanding it also matters, whether you are theoretically very sound in taking those decisions. And the other point which I see is our ability to manufacture it at a lower cost compared to many others. Our industries have been supporting us in a big way, not taking too much of profit or rather their own pie in building things for us. Right. Many a times we create the passion and interest in the industries to do work for us, which actually produce things at substantially lower cost. Of course, our manpower costs are also lower compared to the global standards. So all of this put together, we result in a
lot.
Yeah.
So it's amazing to see that we are able to do things at in a really frugal manner at low cost, and which makes our industry also quite globally competitive. We are at par in terms of kind of complexity of missions that we've been able to do, and rightfully so. Like whole country is very proud of what we have achieved. But I want to go back to the beginning of ISRO. I think from what I understand in in 60s, the entire ISRO program was conceptualized. And it was very unconventional for a country which just came out of independence movement. We were very poor back then. What do you think about the foresight that must have required to invest in space program and nurture, which is finally culminated into kind of things we are able to see today? But what are the thought process behind then to start and fund whole space program?
I must tell you that it must be because of the visionaries we had at that time. There are many. They were in government, they were in public spaces, they were in science and technology. In looking at socio-economic situations, we can spot those bright people here and there. They were coming up. You can look at in agriculture, you can look at milk production, the Korean, the Somanath and atomic energy, the space, the infrastructure that came up in terms of steel and power. Like that in space also there was a Sarabhai who thought about that its impact of space was very clear to him, at least in his thought process. Both Homi Bhabha and Sarabhai together, I think they created the vision of both space and atomic energy. And another important point is at those points they were the visionaries, but they had the access to the decision makers, the power centers, the government, and they were capable of enough to influence them to so that the money can be invested. And of course they packaged the whole thing in a manner that is suitable for the political system to understand the impact of it. And I must tell you that the program like the SITE program, which was very unique, bringing a US satellite on top of India, beaming television program to thousands of antennas, dishes which were established to show that the Akashwani, which was producing television program at that point, was beamed, which is more of related to agriculture. Then political system can talk to them. They can actually reach the messages much faster than they could ever do it. So the showcasing this was very important. And also I remember the scientific outcome which was demonstrated, like looking at the disease of coconut plants, which was demonstrated by remote sensing, by flying with aircrafts, showed that this type of activities showed that it is possible for India to invest, may not be heavily, into this sector and slowly build up that capability. And this conviction leadership was very, very important. And I believe that paid very well for the rest of the growth of this country. Yeah.
Amazing. So back then they had the vision, they had the ability to influence policymakers, and they had the showmanship to demonstrate, how things can actually influence the life every day.
It's not just technology that's needed. You need to understand how the society react to this. And unless you merge these two, it's not possible to make a huge impact in a country like India or anywhere in the world, really.
This series Space Boys, got a lot of attention. Do you think they got mostly right? They portrayed the story well in terms of how, of course, a lot of drama, which is quite, but in terms of the core essence of, what these people were able to do for space program?
I believe so. The movie conveys the essence of the core of what you mentioned. But of course, there is a lot of drama in portraying that. But the journey was not easy at all. I think we must realize that it was not easy in bringing people. I think this is also a magic that Sarabhai was able to convince people who were not in India. At that time, many of them were from in the Western and the US. And he went there, talked to them, influenced them to come over to India and then start a lab in such adverse situations, and laboratories were set up in sheds. For those people who had a great life there, they came back because they were passionate and they were influenced by this personality. I think that's very important. I think there is a little bit of magic in all of that. Hey?
And the ISRO origin story is perhaps told in Space Boys, but I think the ISRO journey also in last 50 years is quite. I think that's still the series or movie is still yet to be made, right?
True. I think one day it will be made, I believe.
Right. And so going back to your early career, Dr. Somanath, so you chose to study engineering. I think you did your PhD in mechanical engineering.
Yeah.
You knew back then also you want to work in space. How did you end up in space? And from there on to become a ISRO chairman, what does it take to get to?
No, it was almost certain for me that I want to work in space while I was in engineering. Mechanical engineering I chose because in fact I loved electronics more than mechanical, but I couldn't get at that time admission into electronics because of my marks at that time was lower enough to get only up to mechanical. But I continued to remain passionate about electronics at that time. But then mechanical helped me to understand many things. But by the time that I was interested in propulsion, so I remember still that I asked my professors in the college to give me an optional subject of propulsion, which was not available there. Then I influenced the professor to teach me as an elective because I wanted to study propulsion, and because my goal was to get into rocket design. Okay. So that was almost I was very sure
Since
about.
at what age you knew you want to get into this?
Even when I was in maybe in +2 that time frame.
Oh.
But before that, I wanted to be a doctor only because I loved biology. In fact, I was a topper in the state for biology. But then somehow I couldn't study biology and become a doctor. But then I went into engineering, and in engineering studies itself, I made it a point to that I developed that interest. But then luckily at that time, recruitment was going on for the PSLV program, which was just starting. So we were all recruited by Vikram Sarabhai Space Center at that time to this program.
Outstanding. And just so let's go to the PSLV. I think it was developed in 80s.
Yes.
Right. And by that time, I think ISRO had enough confidence and funding to be able to, PSLV was back in the day a very ambitious program to be able to build an indigenous rocket. I think from what I understand, we used to build satellites till that time and use Russian rockets to put things in space.
Yes.
So, did you join ISRO when PSLV was in development?
See, when I joined the project PSLV, at that time, many of us were recruited and the PSLV project was just being created. The project was still in drawing board. No hardwares were made. We were only seeing paper work. So that was the time, 1985, I joined. But those team was actually the team which built the SLV-3. Dr. APJ Abdul Kalam just left the team, and his second layer of people were the one who were actually building the PSLV team, Dr. Srinivas and Madhavan Nair. All of them were there part of the team. And I joined the team because I wanted to be part of such a team. I demanded that I should be put there while I joined. Then it was next 10 years of work. By 1994, we were able to see the whole of the PSLV taking shape. So the facility build up, the design, the hardware, the industry interfaces, all that I had the fortune to be part of.
That's the other amazing thing about ISRO. Usually, like most of the launches, in the second or third attempt, we get it right, which is incredible. Like you said earlier, and a lot of in space is difficult, and even smallest possible errors can cause a whole thing to blow up. It's quite commendable for, after 10 years of development, you get it right in just second attempt.
In fact, I must tell you the GSLV rocket, which was successful in the very first attempt.
Wow.
The LVM, the rocket, which is the current rocket, which is successful in the very first attempt, and it has already clocked 7 successful flights, no failures. The PSLV, the very first flight, and the 37th flight was a failure. All other flights were successful. So I believe that the design is good, and the understanding of this came out of very important 2 lessons. One, the SLV-3 program, and after that there was another program called ASLV, Augmented Satellite Launch Vehicle Program. These 2 were the training grounds for building rockets. In fact, they struggled a lot to make that 2 rockets successful, and many of the knowledge that we have today, which is not really in textbooks, you can't actually find it. And many of them are through the experience and the tacit knowledge that we have, came out of that experience.
Got it. And so PSLV has become a workhorse. I think it has been, I don't know how many, but...
now we have clocked 60 launches.
And sir, any reason why, PSLV is so reliable and able to put satellites in orbit, but over 25 years, 60 launches, versus, India could provide satellite launch service to other countries and so on. Is that a deliberate choice, or there are some restrictions that we are not able to do?
Not really, because I was part of the PSLV project. I can tell you the launching other satellite was never in the agenda.
Okay.
The whole purpose of PSLV development was to meet the national demand of launching remote sensing satellite for polar sun synchronous orbit. That's why the PSLV itself came. So then we realized that after launching some of the satellites, we realized that we can do many more things. Then we started launching the first time geosynchronous launches using PSLV. The first communication satellite was launched. Kalpana was launched. Then we had the mission to Moon and the Venus mission. All that it did, PSLV did. I was part of the PSLV team in the early part. So I know that we proposed that why don't we launch commercial satellites using this? And I was the first project manager of doing that task in PSLV.
Okay.
So the first satellite was from Proba, Belgium, and Korea, KitSat. These 2 were brought to PSLV, and I engineered the entire interface of how to handle the private auxiliary satellite, it was called, along with the main satellite. because the payload of PSLV was growing.
Yeah.
Earlier it started with 850 kilogram. Today it's almost 1,600 kilogram. So with that growth in payload, we were able to accommodate satellites, engineer the whole of this. Today we have launched up to 104 satellites in one go.
Wow.
So this idea of launching customer satellites and interfacing that came little later. Then the question of where to source these satellites, where from these satellites from. The primary satellites, the big ones, were not much forthcoming. But we launched about 5-6 of them. But most of them were small satellites, which are meant for nations of various nations, including US. We have launched. So till now we have launched almost 430 foreign satellites using PSLV.
Right, got it. But something in the space industry also changed in the last 15-20 years, mostly because of arrival of SpaceX. It was not something that private players could even think of participating.
Yeah.
But suddenly, SpaceX, I think it was a struggle for them also for 10 years. But then they built this capability, and now from what I understand, one of the lowest cost launch vehicles in the world, and 90% of all the material that's put in orbit is through SpaceX. Is that something, some bit of a missed opportunity for us, or an opportunity in future to be able to participate? Because we have the technology, we've been doing it so successfully and reliably, and I would like to believe it probably very competitive as well, cost-wise.
See, we must also understand, people were trying to develop a reusable rocket for last 25 years. There were many attempts in US primarily. There was a rocket called Roton, which was reusable with helicopter-like blades to come back and land. There was Kessler K1, which was developed and which was based on a horizontally dropping using airbags concept.
Yeah.
And many of them actually flew, but failed miserably. The whole success of SpaceX is because they also flew and failed in the early part. They were able to withstand that failure and come back and then try again. And from the story of SpaceX itself, that he was almost about to close down the program, but then got the success at some of the flights.
Yeah.
So the success and failure in rocket building is about your resilience to handle failures and still come back. And if you are not able to do that, you will fail.
Yeah.
So SpaceX, we must thank him with that. We came out with an idea, which is a reusable rocket idea, which was always being discussed. It's not a new idea itself, but then you need to have an engine which is throttleable, restartable. This engine actually came to him from the work of NASA. Okay, so he relied on a previous work and then improved upon it and made that whole thing work. And even landing was not successful in the early. So rocket launching happened, landing again took some time to perfect it. So the whole engineering concept, the ability of making it the production line, he also changed the way in which the American rocket industry was working. They were all working on subcontracting and sourcing and then integrating as a concept. So he changed everything. He brought everything under one roof, which was the way in which ISRO used to work. Even now we are working like doing everything under one roof because it actually produces cost effectiveness and reliability. So he adopted, in fact, that type of concept. So we should be very, very, very happy about that success that has been finally achieved.
Right. See, on one hand, ISRO has created so much indigenous technology. So we have, in many other technology areas, we don't have strategic autonomy. But in space, we have absolute strategic autonomy. I think from what I understand, nearly everything is designed, manufactured, all the IP is here in the country, and so on, which is quite significant. While we are not translating to commercial revenue opportunity for the country, but from the defense point of view, just strategic autonomy point of view, it's a huge capability.
No, that came out of some of the very strategic initiative that we had in the early part of that. For example, I'll tell you, when SLV3 started, we had a solid rocket technology. The SLV3 was based on an American design called the Scout rocket. Though it was not a technology adaptation, but it was a sort of a mimicking and trying to develop those similar rocket. But then we quickly realized that we need to go to liquid engine building. Without that, the PSLV was impossible. Then ended up with an alliance with the French, SCP France, to build a liquid engine jointly. The French and Indians joined together to develop the Viking engine and the Vikas engine, which we use in PSLV today. That association gave the knowledge into it. And later, when we wanted a cryogenic engine, we went with an arrangement with the Russians to source that engine. They later developed in India. So the whole of ground infrastructure, processing, cryogenics, etc., the learning came through that association. So it's very important to have strategic association, alliance with people who know it, so that you can actually jumpstart from some point instead of trying to develop from the scratch. But once you have reached some level, this will not be happening. So you create certain amount of capability, then look at it, how you can scale up. So same thing is happening for semi-cryogenic. We worked on it. We need to work on electric propulsion, interplanetary travel, space station building. These type of alliances are needed. Even human space, we are talking about how to really work with others to create the capability. So the decisions at those appropriate times helped us to, scale up and then, becoming, you call it indigenous, but then it also has an element of working with others.
Understood. There's a lot of collaboration, some knowledge transfer and so on, and building on top of it. But the entire manufacturing is all 100%.
It's not only manufacturing. See, the technology associated with all of this is actually internalized already.
Okay.
So we know why we are doing it. That answer is already there in the system. Of course, manufacturing is there. Then we have the indigenization of materials, sub-elements, parts, including nuts, bolts. We have to indigenize.
Yeah.
I remember still when I joined, the entire nuts, screws, bolts, etc. were all imported. Today we don't do that. Indian companies are able to make aerospace quality fasteners, which they are actually exporting for other aerospace companies in the world today.
Got it. And just coming to the rocket technology itself. So when we went from PSLV to GSLV, one is the range increased significantly, but did it also require technology to be in some ways upgrade significantly? It's a fundamentally different technology, or it just mostly engineering challenge to be able to build a larger rocket?
There is a huge amount of technology upgradation. For example, one or two examples I'll tell you. For the steel which you use for building a rocket, the SLV3 used a steel called 1566. It's a moderate strength steel. Then for PSLV, we wanted a maraging steel we call it. It's M250 it is called. This steel is critical for PSLV. Without that steel, there is no PSLV. With the SLV3 steel, PSLV is impossible to be made because its mass will be too much. That will not take off and produce any. So this alloy development, not only the alloy development, its processing, its scaling, its manufacturing sheets and forgings, welding technology, its fracture toughness. This became a development program lasting about 6-7 years.
Got it.
And so many people associated, the Mithani, Misra Dhatu Nigam Limited, then the Rourkela steel plant, and many other laboratories across the country participated in understanding this steel. And this steel is now produced 100% in India.
Got it.
Forging steels. And never ever it happened. Such a high quality, high strength steel was ever done, not in any sector. And you look at how to manufacture aluminum tanks. And original tanks, I remember, I was part of the PSLV. So those tanks came from France. The first of the launches of PSLV tanks came from France. How to process aluminum. The alloy was called 7020. Welding, very thin structures, how to handle pressures, how to... You are not even allowed to touch with your finger. They say if your sweat touches, it will corrode and get damaged. I remember that. But now we are able to make hundreds of tanks in India, in HAL, and many other industries. Then learning that came how to design the tooling, how to weld them, how to qualify them, how to chemically mill them, how to understand the metallurgy of it. This knowledge is a huge growth.
And what next in terms of just, I'll come to other programs, but in terms of just the rocket technology itself, so where we're situated, the capabilities we have, and the things we want to do in future in terms of other kind of exploration, going much further.
Yes.
How does the rocket technology needs to evolve in the coming years?
See, the rocket technology has traditionally been the same. See, in fact, if you really look at the technological growth in rocket, it is not very substantial.
Same,
the cryogenic, semi-cryogenic engine which they originally developed for Saturn is still one of the best engine that you can ever build. But then the whole technological growth in space is actually in bringing down the cost, not in improving the complexity. How to simplify it, how to produce in mass, how to bring down the cost of production. This becomes a focus. And that's why the SpaceX is the right model. It's not the growth in technology alone. Manufacturing becomes very essential part of it. Low-cost manufacturing, mass production approaches. Earlier, they were making only one rocket at a point in time. Now, you have to make hundreds of rockets, hundreds of assemblies. Engines are produced every day to 1 week, one engine. Even satellite production also has changed into automobile production line. So this is a change that has happened. So we are also looking at in that way. But if you look at the technology growth in rockets, there is still not a method other than the chemical rocket propulsion that has emerged in the last 100 years. Better than that, than Constant Tsiolkovsky, the Vanguard, all of them brought out the same technology continues. But if you look at the space propulsion, there are new things that came, that ion propulsion, electric propulsion, nuclear electric propulsion. Those emerged, and those becomes the part of the current generation of propulsion for spacecrafts. But to overcome Earth's gravity and go to space,
Still the chemical base.
there is only one technology.
But what did, if you look at something like the Starship, that SpaceX has something like 33 Merlin engines that work in conjunction. So is that something that we are also working on to have that kind of capacity and payload, or we don't need that?
So need is again a question of the vision that you are setting for yourself. For example, the bigger rocket that SpaceX is talking about is created out of a business model, which he says that we will go to Mars or you will use it for intercontinental travel. And it is a fully reusable concept. So the 33 Merlin engine and the upper stage engine with the multiple engines to the two stages is a result of such a business model. Still it is yet to evolve. So I believe such a model, if you are able to make a business model, then such a rocket will be feasible. But right now that such a model applicable to us in India is not visible. Whether if you make a model rocket of that, you will make it commercially viable to sustain it. Whether we will be looking at a Mars transport to Mars and then create colonies, as Elon Musk say, whether it is a feasible model. I think no one here is convinced to fund and create it. So we should look at what is needed for our nation and then develop capability. So recently we have got approval for building NGLV, in the next generation launch vehicle, which is going to be a reusable rocket. Like the SpaceX, the booster will go back and then come back and land. The upper stages will go and get expanded. So such a rocket which is based on semi-cryogenic engine, methane engine and cryogenic engine is going to be used. So it's a question of need-based development.
Right. Got it. Yeah, I think, anyone who works in space or space enthusiasts, there is this whole business side of things, what is a vision, business model and all that. And there is this, more space exploration, understanding what's out there, national pride and so on. So there are two different motives, right?
Yes.
All of us, I guess, space in some ways develops slowly, but all of us are impatient to, at the very least, explore our solar system as far as possible in our own lifetime. So some of these motivations come from there.
This is important for a nation. I think we need to set some of this vision also, because for a nation, once you reach a threshold of economic prosperity, these things become important. So it was not so some time back. Today, as a nation, that we are able to invest some more money into exploration. That's why there is a more interest in exploration has come. Going to moon was criticized upon at some point in time, but it's no longer. Human spaceflight was seen it as not a right thing for a country like India, but it's no longer. So that's why we are courageous enough to speak about going and landing on the moon at this point in time, because it is possible for a country like India to afford. And if you don't do it, it is actually a crime, really.
No, absolutely. And I think the softer aspects of it, this Chandrayaan 3, and the amount of pride it engendered in everyone, including, I'm sure, a lot of kids. Their dream was born that one day they want to either build a space company, work at ISRO, do something, right? I mean, these things are also the soft power of these things also.
Soft power is important, but it also has a benefit, which is in terms of the technological progress. It also kindles activity in domains which is a high technology area. In many electronics, software, automation, robotics. I think this activity also will create interest and work in many fields.
Right. And so we are, from what I understand, we are very close to the human space flight. Is that, I think from technology point of view, you think, we are ready, we have figured out everything. It's a matter of getting the security standard, or at least the enough testing done to be confident.
Precisely. We understood all what is needed for human spaceflight. There is no lack of understanding. But developing and qualifying and certifying before it actually put to flight is a time-taking process. Though we had some concepts that we will be able to buy some items from the other sources, couldn't materialize because of various reasons. Cost reasons, schedule reasons, and availability reasons. So then we took upon ourselves to develop it. Like the environmental control and life support system, which is a very crucial part of it. Then we looked at the crew module. We thought that it can be manufactured from outside and brought, like we did for the propellant tanks. But couldn't happen. Then we have to create the entire manufacturing capability of the crew module, which is a pressurized vessel. So then we handed over to industries in India who is actually going to deliver in few months. So that is going to happen. So many things, such things we have taken on ourselves to develop. But there are few more things to be qualified. And human spaceflight requires certification. The certification process is like not like a aircraft certification, but it's also very elaborate in terms of number of tests. I can't talk about the way in which we develop rocket with the two static tests we fire, but when human is involved,
Right.
the number of tests will be in a very large matrices of possibilities should be tested and proven.
Yeah.
So that goes through some timeline.
And I don't know if you are able to publicly comment on it or not, but are we going to see that happen this year, next year, very soon?
Yeah, the first uncrewed mission will happen this year.
Okay.
And all preparations are going on. I understand the rocket is under integration now.
Okay.
And the crew module and the service module, etc., are also in terms of the assembly and testing activities are going on. So it's moving towards that.
So very soon in near future, we'll see Indian astronauts going to space in Indian rockets.
No doubt about it. No doubt about it. We are in the right track.
Amazing. That's great to hear.
Yeah.
What's next? Like in the near horizon, what are the other things? So this Chandrayaan 3 also. What's next? Like what next milestone we would like to see happen in the coming years as far as being able to go to moon?
See, to going to moon, it requires many more technologies to be to be understood and actually. For example, the docking.
Yeah.
You heard about the docking, the SpaceX mission. It was the first attempt to dock in a circular orbit with two small spacecrafts, and again done extremely low cost. To do such a mission at this cost, it is impossible. So we were able to do the successfully docking in the very first attempt, but that mission is continuing still. So some more work is going to be done, but that's not enough. If you really want to dock to go to moon, we need to do docking in elliptical orbit. So we need to do another mission to do an elliptical orbit docking. Then we have to build a docking station which is as big as a human craft people can go. So the standard docking interface for human spaceflight is to be launched, and we have to dock.
Okay.
Then we have to dock with the International Space Station and see how we can work with others and dock. So collaborative docking processes. So these require step-by-step missions that will demonstrate them before we actually venture into actual mission landing on the moon. That's why we announced a Chandrayaan 4, which will have elliptical docking, then going to dock in moon orbit, then restarting from the moon and go to a moon's orbit like a rocket in moon.
Yeah.
So all those elements are put into Chandrayaan 4 and we got an approval.
Got it.
So this is one. Similarly, we want to go to missions like going to Venus and land in Venus. Venus is again an interesting planet where it has a thick atmosphere and how to enter into Venus atmosphere.
And just for people to visualize how thick is the atmosphere, like how do you even visualize, what's
it is possible to measure. From here itself, we can do that measurements. The atmosphere here is one atmosphere. We call it 1 bar or 1 kg per centimeter square approximately. So there it is 100 times thicker.
So as I know the temperature is also very hot, but you can't probably even walk like it's that thick.
No, it won't feel like that thick in terms of fluid flow thick, but it is the pressure will be so high. So any human being which is put to there will be crumbled to a small size. You can understand that it is equal to 100 atmosphere is equal to 100 into 10 meters, 1 kilometer deep inside water. If you go, what is the pressure there? That's the pressure on the surface of Venus.
Right.
So that pressure, nothing will withstand. Even electronics will not withstand. You take a chip there and put the chip there. The chip will be pressurized. So the construction of the chip, electronics, cannot even withstand. So even you design an electronic part which will go to the surface, it will be in a container which can withstand that type of pressure.
Got it.
So electric cables, electronics, communication infrastructure, many things. And even that's atmosphere is acid. Okay, it's not so everything will get corroded. So how to drop something into that and reach the surface and measure? It's again a huge challenge.
So far, has any country been able to land a rover?
Yes. No, rover has not landed.
Okay.
They were able to put balloons and probes into it and then do measurements.
Got it. So we have not landed anything on the Venus surface as
No. We want to put a probe into it and then see how it reacts to it.
Right.
But it's an engineering challenge. Yes.
Got it.
Yeah.
What about this? I'm asking a question maybe from both ISRO's behalf, but also just the global space program.
Yeah.
When do we see man or woman, preferably, back on moon?
I think Americans are serious on it. They want to send human to moon very soon, and there is a program now which is already announced as the Artemis program, which they are trying to create actually a space station around moon and then to have a continuous human missions to moon, to create an outpost there and to have a successful business model of sending. But this, the whole Artemis program is also under review. And there is another competitive program to go to Mars. So there are two schools of thought. One is a moon-based economy and another is a Mars-based economy. So which one is going to take up the the real work in the coming days yet to be seen based on the changed scenarios in US. Even Russians are also talking about moon mission. They also have a plan to launch a space orbital platform to go to moon. China has already announced outpost in moon.
Human
Human based, and including a space station around Earth and to have a continued travel back and forth. So such models have been already announced by most of the nations.
So based on everything you know, next 10 years, do we see a human again landing on moon?
I believe so.
Yeah?
Yes. Because that the significance of moon has again been understood. And this is because of two important changes that has happened. One, going to moon was a thing of more of show at some point in time. Today it's no longer. They see a benefit of going to moon because it is a strategic outpost.
Yeah.
So they also see there is also a reason that the cost of access to moon has come down dramatically. See, for a country like India is able to put a craft on the moon, it also signifies that it is possible for many nations to do that.
Yeah.
Okay, with such a low cost, which was not possible in the past. Okay, so the Saturn program took almost 30% of the GDP of America to build it. Today, they can do it at much lower cost. So the access has improved and the potential benefits are visible now.
Yeah.
So there are more people.
And is there a international treaty in place in terms of, if a nation is able to land on moon and claim, this part belongs to me? Or how does it work? How do we navigate, who controls what?
Not exactly, but there is a moon treaty which talks about how we will use moon for the benefit of the humanity without creating conflict, etc. There are some general framework on how this can be done, but there is no ownership transfer or anything. Everything is to be used for the entire humanity. It is not to be partitioned. But then how the world works. For example, the Antarctica treaty is there, where each nation, whoever has gone there, has been claiming certain area where you operate your. We also have our Parthi station where we put our ground stations. We use our satellite ground, and our people are always there in that station. So it is similar to that. So many of the planeters, when you actually go there and claim, those who go there will definitely have rights.
Wow, okay. And look, world is also getting very depolarized now. Trump is talking about taking over Greenland, maybe Canada, maybe Gaza Strip and all of that, and pulling out of many treaties. So maybe there's moon treaty, it's not a given that I guess every nation will continue to...
No, such things happen. World is like that. Every now and then you will hear such ideas and concepts. But I believe that the approach of humanity should be to use such resources in a very equitable manner without creating conflicts and to the benefit of the humanity. I think we should stand for such ideas so that it is accessible to all. But then, of course, those who put their effort must have a pie. And it should not be on a shareable basis for the betterment of the humanity. Of course, if it is so, then it is good. But it actually causes harm, then we must be careful about it.
And just from purely looking at space from commercial point of view, are there meaningful opportunities to be commercially exploited at moon or Mars, or it is mostly still scientific exploration?
No, this is a great question. I think we need to debate on it because there are many articles and books written on this aspect. How to really commercially exploit moon? What exactly are the tangible benefits of this? Similarly, Mars, terraforming of Mars, converting Mars to a habitable place, creating colonies of people there and make them live. All this won't look very appealing to us at this moment. Though it may look like a science fiction movie, but it has a significance. The significance comes out of the dangers that we have today on Earth. We don't potentially see the danger. See, for example, the life on Earth was destroyed at least 4 times by external influences, by meteorite impact or destruction or whatever.
And there is some data that I think just under 100,000 years ago, at some point, human population dwindled to few thousand.
Yes. So it can happen again. Anytime it can happen, and the warning that is available to you could be very, very short. But then that's why there are initiatives world over, like spacefaring nations work on programs that in case such external object come and try to hit, how to divert it and protect Earth. There is a movement, all spacefaring nations to join together to such a move and then prepare ourselves. In case an apocalypse comes and then we are forced to leave, how do we really settle somewhere so that until the dust settle here and Earth comes back to life again, we can come back and then restart the life again instead of getting destroyed and restart from the amoeba or rather the single cell system. So this type of
4 billion
debates,
years last time. Yeah.
the whole advantage that we have today that we are able to foresee this and act on it. If human beings are not acting on it, then who else can do that? I think it's appropriate for us to think about it and then work on it.
And on that note, then on Mars also, then you think, you said moon, maybe in the next decade we see a human land on moon.
Yeah.
Mars, 2 decades, 3 decades?
No, Mars, it takes time. For example, as per the Elon Musk, he says he will create lakhs of people to move there, create Mars colonies. But then converting Mars to a habitable planet, it will take time.
Yeah.
There are some studies done which estimates that at least 100 years are required to do a terraforming and then create a oxygen-rich atmosphere, reasonable amount of those type of things, provided there is water and things like that. So there are ideas of that nature. Moon could be much easier, but there is again resource crunch is there to create moon colonies. It must be mostly underground. Creating an atmosphere in moon is virtually not possible because low gravity.
Yeah.
So without atmosphere, the issue of radiation, meteorite impact, then people have to live underground and then live. So those approaches are possible, but moon will not be a permanent outpost. It will be a temporary outpost. People can come and back, but Mars going to be one-way traffic mostly. Going and coming back is not really possible because it takes months unless you have a different type of propulsion. So each has its own models. Yes.
Did you ever get a chance to read this Kim Stanley Robinson's Mars trilogy book series?
Yes.
Yeah. This is very, in some ways, science fiction in many ways.
Correct.
But do you think there are parts of the book in terms of, possible evolution of Mars, colony, he gets it right in the book?
See, there are much of ideas that are put into it. It's possibly not realistic, but then it's a subject that we can always debate, discuss. Why not?
Right.
Okay. We can't say that it is something impossible.
Yeah.
Anyone who says something is impossible is a fool, really.
Yeah, definitely. The history of last 100 years of science is that we are increasingly able to do things. What about beyond Mars? And just from exploration point of view, are there interesting planets or satellites that we must get to in
I think that is more important for us. For example, the planets around sun are limited in possibilities because the Earth is at the sweet spot where the temperature is right, the water is in liquid form, the life can sustain. But similar planets exist elsewhere, other part of the other planetary systems around other stars. But they are not nearby. They are hundreds of light years away. But they are identified, they are located, at least hundreds of them. Out of those 5,000 odd or more exosolar planets which are identified. But we still do not know how to reach there. The reaching there takes not many more lifetimes. But still, I believe the science will grow to a point that the path to reach up to that will be discovered. It's a question of time.
Yeah. But even the beyond solar system is obviously take a lot of time. But what about satellites of Jupiter and satellites of Saturn? Are they interesting?
They are interesting in terms of it, but then they are small ones. Some of them little smaller than Earth. Possibly they can keep life for some more time. But they are transient storage of life. They should still come back to Earth and then live.
Right.
If anything happens to Earth, there is no better place on Earth to live on Earth's sun's planetary system. Of course, they could hold some life. But the real thing that we should look for is an exosolar planets, in my opinion.
Got it.
But then the approach to reach that is still not visible. Maybe it will come in another 1,000 years of research and work, or more of physics understanding of how to travel in shorter distances than that we.
But are there technological developments happening? You mentioned some of the space-based propulsion systems. Are some of the systems have the potential to at least send things one way at the very least, so that we can see what's there? And
definitely, there are ideas like the wrap drives. There are antimatter propulsion. There are concepts like the harnessing hydrogen ions.
These are paper concepts?
Paper concepts plus some engineering concepts are developed. For example, the entire space is filled with hydrogen. So you will find in every cubic meter a few atoms of hydrogen. So on the way you collect them, you use a power and then convert it as a propulsion and then move forward. Ionic propulsion. So concepts like that there. Then wrap drives and things like that. So there are ideas, but ideas to be converted into physical realities could be a centuries of work.
Got it. Okay, bringing this conversation back to Earth. This is more from your startups point of view. So until 2020, I think it was not even possible for a private company to explore something doing in space, but the creation of in space, it become possible. And we have seen like a lot of startups come up. One I'm been involved from the beginning, Skyroot, which I think Pawan worked with you in under your guidance for a long period of time. There's Agnikul, and then bunch of satellite-based companies. What do you think about how is the private space ecosystem in India, and are there possibilities for these companies to really build meaningfully sized business?
Definitely, I believe it is the time is right now for them to start working and scale up. Sometime back, the potential of doing such activities was not there. And realizing the global change, I think we have rightfully created the space sector opening announcement by the government and creation of the space policy of 2023. Helped the creation of the in-space to handhold them with the help of ISRO. All this has happened now. Now it's a question of finding the right path. And here there are challenges. I must tell you that it's not an easy thing, but there is a huge amount of opportunity visible. In my critical assessment, I believe that we must grow in all sectors of space because, you see the space sector upstream work with the rockets building and complex technologies, midstream work on moderate technologies, which is more of building satellites and launching them, the downstream work on applications and infrastructure and associated services. I think all these sectors have their own potential. But the biggest money maker or the domain that sustains the other one are the downstream work. So I have seen huge success in downstream. Wherever the startups and companies coming in space sector, application sector, service delivery, I am able to see lesser risks and huge returns. In India, being 140 crore people, I think the huge market still unexplored. So I think our effort should be in creating space-based application delivery to larger number of people. And there is a huge domain possible. So I look at young people looking at coming here and then creating. That will create demand for building more satellites and launching them. And bringing up innovative technologies in the domain. And they will be initially launched in various ways. And such startups like Skyroot and Agnikul will be able to capture that demand for launching, building and satellites in the initial phases. And once they reach a threshold, we will see that the scale of rocket launching cannot limit to the small ones, then the big ones will come. So this is a growth that need to be engineered over a period of time. But there is another model like SpaceX did. You create the big launcher capability and create a downstream business case. Like create the Starlink constellation. Came out of the ability to launch at a lower cost using a rocket. So there are different models. Whether that model will work in India, yet to be seen. But I am able to see the downstream growth accelerating, leading to the upstream growth is the one model which I think it is the right model for India to scale up.
You will say your suggestion for prospective, let's say, entrepreneurs who want to work in space to think of a use case of what service can you build which is space-based.
Correct.
And then you can use maybe even today someone else's satellite or rocket, etc. And as more such use cases grow, automatically somebody will respond and create those.
Precisely. I will tell you a few use cases which is still not explored. Possibly, look at it. We know that there is a fish catch. We give a fish advisory. INCOIS does it. Our OceanSat satellite using the ocean color monitor, sea surface temperature, the wind, etc. We predict where the fish school is there. This advisory is available free of cost to the local market. But then the utilization of that is not huge. Can you convert it into a business case? Okay, you provide this service on a cost basis to people at their doorstep who actually go out for fishing. And if they bring a catch which is better, then you get a return and convert it as a business model. You can do it in climate and weather advisories, which is still not grown as a market here. Like that, you will see that it in agriculture, in IoT, in logistics, in many areas, the space is still not explored enough in the downstream. Education, for example. So there are many sectors where startups, companies can actually come in and then create new business cases.
And all these based on the low Earth satellites, the data that you can capture, or even geostationary satellites can play a role?
All of them will play really. For example, the OceanSat is LEO satellite, low Earth orbit, but some communication infrastructure is called for. You need a geo. So it's a mix of communication, remote sensing, position navigation timing services. You need to use Navic also because you need a location services, which otherwise you have to pay to the other services. So you can integrate them and then create an application.
Got it. It's almost like there should be some space incubator which can, help. These common services are available,
Yeah.
and then the entrepreneurial spirit is about translating all of that to a use case. For you say for 140 crore people,
Yeah.
fairly large country, so much diversity of climate, agriculture, and so on.
Yeah.
Got it. What about so one of the things that as humans, two things for ages people in wanting to do. One is exploring space. Other is being able to just fly. Just use the aerial route. Today morning all of us struggling with the Bangalore traffic.
Yeah.
Where do you think this whole drone-based technology, and are the air taxis nearly there? Can we expect them to be part of our lives soon?
I believe so, because the growth in air taxi concepts like the drones, many concepts are developing, and many of them are really going to be the one which is going to be operationalized. Only thing is the ground rules are still not set. How to operate them, how to regulate them, how to bring in safety assessment, certification of this is still not very clear. I think that part is to be taken care. It is randomly growing at many places. This random growth need to be regulated.
Yeah.
So I believe government will bring in some the regulatory structure for control of the airspace, where drones will come to for local taxis. What type of infrastructure you need to create for where it will land and operate.
Yeah.
What are the rules and regulations of the people who will pilot them? What is the navigation approaches and who will monitor them? To avoid collisions and collateral damages. What are the insurances approaches for such a journey? So these aspects need to be urgently looked at so as to create a operable framework and then start it. I think then you will see the growth.
Have you personally seen any working prototype where
Yes.
as a human you can get into this space?
Yeah. Many of them. I think many of them are, for example, some startups in IIT Chennai I have seen, they were really made a compact composite, and recently I observed one of a different concept which is in scale model they have made, and big scale model startups are able to make. And another equally important domain is the growth in the power storage, the battery technologies, electric motor technologies. Those type of things are also growing right now. For some of them are being procured outside, they have to also grow indigenously once they scale up.
And a lot of these technologies which are, they're mostly you can say in the aerospace zone, are they all on the radar of ISRO in terms of thinking?
No. ISRO is not working in the drones of what you said as personal transport or air taxi concepts. I think we are not there. The agencies like the National Aerospace Laboratory has a wing associated with such drones. And there are other aerospace laboratories like ADA and things like that. Our ISRO space happens beyond 100 kilometers.
Got it. But there must be some technology transfer or some technology, or they are very different set of technologies, materials wise.
No, the technology side, of course, there is an association. For example, the in ISRO's labs works on battery technologies, lithium-ion technologies. So we have transferred the technology to some industries to build high-capacity lithium-ion. We worked on capacitor battery, which is a high discharge capability. We are also working on battery management systems, safety and charging systems, electric motors, and high-power electric motors, which we use in most of our rockets. So there is a research lab in Indian Institute of Space Science and Technology, which is joining with the NAL to develop the electric aircraft. I think those areas we are collaborating. So there is technology collaboration. Not ISRO doesn't directly work on this, I believe.
I want to ask you one question more, on behalf of somebody who is in high school or in college and has dreams about doing something in space. What will you advise on what should they study first of all, and what path they can find so they have the right skill set and the right environment, to be able to do something in space?
See, space is such a multidisciplinary domain. I think the only thing you need to know is the passion and awareness about space. The domains are not that important. For example, I studied mechanical engineering, an electronics engineer, a chemical engineer, a civil engineer, an agriculture scientist, a geotechnical scientist, an astronomer, a physicist, a chemistry. Anyone can work in space. Or a software engineer, a computer programmer, a special computer scientist. We have roles for each of them in ISRO. Possibly you don't know that there are ocean scientists,
I didn't know.
agricultural scientists, geologists working in ISRO.
How many people does ISRO hire each year?
Not much, possibly around 200 to 250 people.
Okay, so that many positions available for people too.
And these domains, there are people needed. For example, we work on forest cover, forest geo estimation. For example, how much is the agriculture thickness? understand its nature. How much is the carbon sequestration? For that, we need people with the background in forestry. We have people with the background in geology for understanding what is a water level, how to understand the maps, and then understand the water content in it, then tectonic movements. There are people who works in ocean science, with us. They look at that science part of it and then build. So all expertise are available of different level.
And are you increasingly seeing even people from ISRO coming out and starting their own companies, etc.? And so, like Pawan is one example of that. In general, is that?
No, there is no stopping of anyone who is interested to go out and then start an industry. Definitely, it's a welcome thing. It actually adds value to the whole sector. Of course, those who are interested to leave ISRO and then start this, many have. It has happened. It is a natural process where in any industry it happens in a private industry all throughout. Many people come out and they start. So it's something that we need not to worry about. But that is very small in percentage. The attrition of scientists from ISRO to start this, not much. So
maybe ask me like, where do these entrepreneurs who are interested in space, where will they come from? If you don't work in ISRO, is there a significant knowledge gap or barrier to entry for people? How do one start? Because it's unlike selling something online. This is much harder entry barrier here.
No, that the technology side still could be harder, but then you can understand the need at the market.
Sure.
So those who understand the need of the market, where you handle. For example, I talked about the fish school catching, and then anyone who has a common business sense on how to put this into application and convert a business case can definitely work in. You can always hire the people who understand the technology and then create the backside of it. Right. I think that you don't really need such a depth of technology to start with.
Understood. Okay, I want to again, just since you mentioned something about research also, just how does ISRO look at more scientific research in progress? Because one of the other big benefits of space is, where you mentioned I think earlier James Webb Telescope. We are able to understand so much about bigger questions that origin of universe, getting these gravitational waves now, getting signals from billions of years ago and so on. How does ISRO look at some of these things and collaborating with Indian science institutes to be able to do some of these things?
No, we have different models for it. For example, we collaborate with most of the science laboratories and institutions in this country and universities. So we conduct workshops. For example, recently we conducted a workshop on solar science or heliophysics. And we brought almost 100 people across the country who have an interest to understand, study about sun and its influence. They come from various laboratories, the Department of Science and Technology, the CSIR laboratories, the universities, and many observatories and schools and colleges. They come together and we give the data. We train them, we expose them, and then new people take up PhDs or research in it, publications. So this happen. Then we conduct similar exercise for Mars, Moon. Then entire data that we get from the space science missions are put in a repository, science data center. And this data is available to all those who register and make it. So the publications come out of this data, which they study. Similarly, world over, there is an understanding that such exploration data must be made freely available to the research community. They take it not only from India, but across the globe. So we can also get similar data from other sources. So it's a global collaboration of expanding science working. It's not only this data utilization, we also need people who create new physics. For example, if you have to find a new thing, you need to develop an instrument, a sensor, an equipment that can be put in a satellite. Who will build it? So unless you understand the physics of it, you cannot actually put an engineer to build it and then finally qualify it and put it. So our, for example, our Aditya L1 mission, the coronagraph came from another institution, not by ISRO. Similarly, our UV spectroscopy came from another institution. So we work with multiple institutions, work with them to create that knowledge, the analytical skill, instrument building. I think all of this happen.
And as you look at, or as ISRO looks at its mission, is advancing scientific knowledge is also one of the key objectives?
It is. It is a key objective for any nation. I think while working in space, adding to the global knowledge is an essential part. Without that, there is no fun in doing it. No, it's just not for commercial work or scientific exploration and getting data, unless you can create a value for it. I'll give an example. See, the finding water on the moon. Now, how significant it is, you know it today. And you know which mission did it? It's the Chandrayaan 1. Okay, the Chandrayaan 1 had two instruments, one from the US side and one from Indian side. Indian side actually observed the water on the moon, and our people were able to understand that it is water, but they were not confident to announce it.
Yeah.
They got they could have perplexed to see the signature.
Yeah.
But then by the time the American instrument came out and said that there is water on the moon, then we went back and looked at it. It is true.
Oh.
So our instrument also found out water on the moon. Now we in the Chandrayaan 2, we brought more instruments and then we proved that there is adequate amount of water on the moon. Today we know there is enough of possible liquid water, ice water on the moon on the southern side. So you look at that, in 1960 onwards we have been going to moon.
Yeah.
But the awareness of water on the moon came only recently.
Yeah.
Only recently.
And this is like, how well do we understand? You said there's an adequate amount of water. Is there a way to quantify it, and how easy it is to, is it
It's
like,
not easy.
Okay.
See, the signature of water everywhere is available. Okay. But then in water which can be extracted for sustenance of life is a huge challenge. That's why we have a mission called Chandrayaan 5 announced, UPEX mission.
Okay.
This will go to the South Pole. It will do drilling on places which is permanently shadowed, where the possibility of water being still buried there without sublimations will be there. Without the atmosphere, water cannot remain as water. Unless the temperature is so lower, it will remain layer. So we need to drill and find out.
I see.
Much more proof of it is needed.
Got it. So there is, would you say, reasonable likelihood that when we drill, there is a buried, basically ice?
That's what is expected.
And if there's sufficient quantity, then it very different possibilities of what we can do on
correct, yeah.
opens up.
Yeah.
Got it. Just zooming out, sir, I think this is maybe as somebody who has worked in space pretty much all your life, you've been part of many significant missions, many breakthroughs and so on. Now, as a someone who is stepping away from your day-to-day ISRO role, what are your expectations from a space program in general? Like as a space enthusiast, what are the few milestones you would like to see happen over the next 10 to 20 years, both in India and maybe globally?
See, I already mentioned some of them. For example, if you really look at the current space, you see an international space station, where there's only one space station up there where human beings go. Right now, around 8 people are there. This outpost is a huge, important research opportunity for us. Going there and doing research in a microgravity environment, space environment. This creates a scientific potential for all of us. But this is a limited access place, very costly place. But there is a huge potential to use. I believe
so we can build our own space
India
station?
has to have our own space station. And where Indians will continuously go and create some value for it. This space station building is only one part of it. But doing research and developing something in microgravity environment, we need to create a corresponding industrial ecosystem in the ground, which will make use of that for effectively.
Right.
So this also should happen simultaneously. So this is one wish list I have, and that space station should be operated in a commercial manner, not just for fun or for prestige. The second, of course, is the mission to go and land on the moon. Its challenge is again huge in terms of technology development, the safety, everything. But it will add value to the entire space program. Our rocket capability will improve. Our autonomous capabilities will improve. New technologies will emerge. And we will also have our share of pie on the moon. But then globally, if you really want to look at, the space is slowly becoming a dangerous place in terms of the number of satellites, in terms of the debris. The ability to operate on a global scale is becoming more and more threatened. The space is also becoming a place where competitions happen because the power of space is now well understood in terms of the global interactions. So I hope that this doesn't happen. We create a good framework on which that this will be continue to be used for benefit of humanity. I also don't believe that you should launch thousands of satellites. We must find a way not to do this in terms of large number of satellites, manage it with a lesser number of satellites. For example, the constellations with 5,000 satellites to do a global communication. And if 2-3 more people do it, you should realize that it's going to be much dangerous. So how to really bring down the number of satellites and still do the same thing with the new architectures must be a topic that we should discuss.
Got it.
India still continues to work on geostationary satellites for communication. But there is an increasing pressure to talk about constellations where it will give continued visibility and things like that. This will happen for Earth observation also. So here again, my dream is that you have a powerful satellite which will go up in the geostation and observe at high resolution on a permanent basis, not really continuously moving and constellation approaches. So we want to build such a satellite and launch geostationary based high resolution satellite. But you need a bigger optics and light collection system, etc. But it will be more economical if you do that.
Yeah.
So we must ensure that sustainability of space is addressed
Right.
while we talk about this commercialization. No, this becomes a very important issue.
And do you also think we are in some way much better situation today? After the moon landing program was stopped,
Yeah.
there were 30-40 years of almost no news. I know India was building its own capability, etc.
Yeah.
But suddenly in last 10 years there is so much more excitement about the possibilities in space.
Yeah, it happens because of the primary reason that now the space is more accessible. The cost of access to space has come down. It's not just because of SpaceX alone. Globally, also this has become possible. Everywhere, the cost of access has come down. Or rather, the economic power of nations have increased to afford space travel at a moderate cost without posing hardships to the citizens. So this creates a new increasing interest in going to moon. So all this exploration happened when you are economically comfortable. No, your primary needs of food security are all met. Then you explore beyond point. So we are at that point. So at this point, I think we should do that. When a safe, secure world is there, people will have courage to explore.
Yeah.
If you have more conflict on the ground, we will have no time to do any of that other things. I hope that the humanity sense prevail and so that we do the work what is needed for our posterity.
Yeah, it's increasingly looking a little more challenging than not. But sir, I want to thank you for taking the time for sharing your journey and your views on the space program. Space continues to be a source of huge inspiration and a source of pride for India because of what ISRO has been able to do. I think it allows many of us to dream, as well as potentially build solutions and services around to move the space sector forward. So thank you so much for all your contribution to the space industry and also for taking the time to speak.
Thank you so much. Thank you so much.
At SparX, we aim to bring to you stories of exponential impact. We share in-depth analysis of what goes behind success stories. If you find our conversations interesting, you can join us by subscribing to our YouTube channel. You can also listen to SparX on Spotify, Apple Podcast, or any other audio platform of your choice. If you have any suggestions on who we should invite or what topics we need to cover, just let us know in the comments. We are always listening, looking for ways to improve, and keep getting better as we go along.